Hello everyone, welcome to my class. In the previous lecture, we have learned about array, the definition of array and types of array and how they can be stored in computer. Now, today we will learn in details how much element we can store in an array and how they can be stored and what will be the address of a specific element present on an array. So our content is representation of array element in memory, address of the array element, and today I will give you some assignment on this lecture series. So first topic is representation of 1D array in memory and address of the element. So here we have this array having 6 elements. So first we have to know what is the lower bound and what is the upper bound. Lower bound is the index from where we start storing the data. Upper bound is the index, how much element we can keep on that array. So the number of array element, it is upper bound minus lower bound plus 1. Here, this upper bound for this specific example, it is 5. And the lower bound, as it is denoted, that is 0. So number of element, what it will be? It will be 5 minus 0 plus 1, then it is 6. So you can count the number of element in that array. It is 6, exactly 6. So number of element always depend on the value of the lower bound. Now suppose someone has chosen his lower bound from 1, then it will be different. For this array, if we start storing the data from 1 index, it will go up to 6. So 6 minus 1, it will be 5 again, plus 1, it will be 6. So always remember that it depends on the value of the lower bound. Next, we are coming to the next option, that is address of an element. One more thing I need to share with you, that if we know the address of 7, then we can find out any address of any element present on that array. Okay, suppose we are having a character kind of array. So as we know, one character needs 1 byte of memory to store in computer. So if we want to know the address of the 4th character and we know the address of the first character, then we can find the address of the 4th character also. So now next I am coming forward for this address of the array element in 1D array. So we need to find out the location or the address of an element present in kth index. Those are the index value. We need to find, suppose we need to find out the address of this 1, which is kept in index 2. So the value of k is 2. Then the base address, which is the address of the first element. Then it is W. W means what? That is the weightage of an element. How much memory byte it will take to store in computer memory. Okay, suppose one element needs 4 bytes of memory. So we have to occupy 4 bytes of memory for one element. Now if there are 10 elements, then we need to occupy 40 number of memory, 40 memory bytes. Okay, so like this way, it is k. Again, it is the index value minus lower bound. Okay, now in many book you can find that it is only written W into K, but it depends on the lower bound value, because if someone chosen that lower bound from 1, then it will be different answer. So always try to write this thing, that K minus lower bound. But theoretically and practically also, we use the index value from 0. That's why they're choosing it as 0. Okay, so what we need to do, we will solve one problem. In a 1D array, A12, with each element occupying 2 bytes of memory. First, let me tell you that is an 1D array and it have the size 12. So if we choose the lower bound value 0, then the upper bound will go up to 11. If we choose the lower bound 1, then it will go up to 12. So here our array size is 12. Each element is occupying 2 bytes of memory, and with the address of the first element 0, means the lower bound is starting with 0, is 200. So the base address is 200, where the index is 0. So find the address of A5. So we need to find out the address which is stored in index 5. Okay, so what will be the answer for this? Here in the question, already base address is given, which is the address of the first element. It is 200. W is the weightage of the element, means the number of memory it needs to store the value. K is the index number, lower bound value is 0. So the answer will be, we just putting the value in this formula. So base address is 200 plus W is 2, then 5, the lower bound is 0. So the answer will be 210. Okay. And for one dimensional array, the elements are stored row wise. Elements are stored row wise. So we are storing the data row wise, so we can find it out very easily. Next, we are moving to the representation of 2D array. So number of element in 2D array, first we have to know how many number of element we can store in particular array. Again, it depends on the lower bound value and the upper bound value. So the number of element, it will be, for the first dimension, we are considering the row. It is the first dimension. Second dimension is column. Upper bound of the row or the first dimension minus lower bound of the first dimension or the row is, here it is, upper bound is 2, lower bound is 0. And for the second dimension, which is column, the lower bound is 0 and upper bound is 4. Here you can see from this picture also. Upper bound of this row is 2, lower bound is 0. And for column, upper bound is 4, lower bound is 0. Plus 1 means now we are replacing the value. Upper bound of first dimension is 2 minus lower bound of the first dimension, it is 0. So 2 minus 0 plus 1, it will be 3. And for the second dimension, it is 4 minus 0 plus 1, it will be 5. So if we multiply this 3 and 5, it will get, we will get the result 15. So you can count the number of element over there. There are exactly 15 number of elements in that array. Next, we need to represent that matrix in computer memory. Now there are two ways to represent these 15 values in computer memory. Either we can store the value row wise or column wise. So what are the values we have? We have in the first row we have 5, 12, 17, 9 and 3. So we are storing the value row wise means first we need to store the first row, that is 5, 12, 7, 9. Then the second row it is 13, 4, 8, 14, 1. Again we have written the second row, then the third row. So we are storing the data row wise. Okay, this is the row measure order. Next is a column measure order where we have to store the data column wise. So what are the values we have? That is 5, 13 and 9 in the first column. So we are storing 5, 13 and 9. Then 12, 4, 6, 12, 4, 6. Like this way we will store all these 5 columns. So you can check for one particular element the address is different in row measure and column measure. Okay, so we need to find out the address in both the way. If we are storing the data in row measure order, then what will be the answer? If we are storing the data in column measure order, then what will be the answer of the address? So we are moving to the next slide, which is the address of 2D array element in memory. That is, if we have a m cross n matrix, suppose we have one matrix with 10 number of rows, 15 number of columns. So the value of m will be 10, value of n will be 15. And we want to find the address of an element in position jk. Now, if we start storing the data from 0, 0 index, then this jk position will be different, and if we are storing the data from 1, 1, then also the jk position will be different. So it's vital from where we are storing the data. It's vital what is the lower bound. Okay, so location ajk, okay, means we are finding the address of, suppose for this we need to find the address of 8, and if the lower bound is 0, 0, then it will be 1, 2. The address, the j value will be 1 and k value will be 2. And if we start storing the data from 1, 1 index, then it will be different. It will be 2, the jk position will be different, it is 2 and 3. So what we have to do, what is a formula to know the address, because it's very difficult to find out the address in this way. Suppose we know the address of 5 is 100, then we can find out the address of 4 also if we write all this in row measure or column measure order. But it's difficult, so we have to find out some solution for that, and there is formula for this. So location ajk means we need to find out the address of jk. It is base address, means the address of the first element, plus w is the weightage, that means how much memory bytes is taken to store the data. Then n is a number of column, j is the index value of the row or the first dimension, plus k minus lower bound. K is the column number for which we want to find the address. Okay, this is the row measure order, and this is the formula for column measure order. Only the difference is here, instead of n it will be m, and instead of j it will be k, and k it is j. Okay, so here we have we will solve one problem, that is, in a 2D array A25-4 is the m cross n matrix, means the value of m is 25, value of n is 4, with each element occupying 4 bytes of memory, means the weightage is 4. with the address of the first element 1 1. Here you can see the lower bound value is 1 1. For row it is 1, for column it is 1. Is 200, means the base address is 200. Okay, so find the address of 12 3. Find the address of 12 3, means we need to find out the address of the element which stored in location 12 3, where the index value starting with 1 1. So we know all this value. The value of jk is obviously j is 12, k is 3, lower bound is 1 and 1. For row it is 1, for column it is 1. M is 25, as it is a 25 cross 4 matrix. The n value will be 4, and weightage is 4, because for one element it will take 4 bytes of memory to store the data. So we are putting the value of this in this formula. In row measure order, the base address is 200 plus 4 into, it is n, value of n. So for row measure order it is n, is 4. 12 minus 1 is the j minus 1, then 3 minus 1. The answer will be 2184. And for in this same way, that in column measure order it will be 2244. Okay, I think you have understood this topic, because it's very easy. We are just putting the value whatever it is given in the formula. So next, it is your assignment that these are two questions. One of the question, the first question, it is I have written it from one competitive exam. Okay, so just try to solve this out, and if you face any difficulty, you can contact me. So thank you for hearing my session. If you face any difficulty, you can write me at trishita.ghosh@gnit.ac.in. For this timing, thank you all.